Bismillahirrahmanirrahim. Dear fourth year students, Assalamu alaikum. Welcome to your second semester industrial pharmacy. New syllabus, new course, and new course title. Today we start from our first topic, that is suspension. Suspension already you have taught in 2 or 3 semesters, but the way is different. In this semester, you have to focus on large scale preparations of suspension. Introduction, we will do introduction. As you know, you have already learned in first semester and fourth year first semester. So you have already know about definitions and methods of preparations. So we in ne- another time we introduce already. So when we see the definition is pharmaceutical suspension is a heterogeneous system consisting of two phases in which internal phases disperse uniformly throughout the external phase. I quickly remind you introduction. So you can recall the topic of suspension. The internal phase consists of particulate matter that is essentially insoluble but dispersed uniformly throughout the continuous phase with aid of single or combination of suspending agents. The external phase suspending medium is generally aqueous in some instance, may be an organic or oily liquid uh, non-agar phase. Introduction classification. Suspension can be classified based on physical state suspension, aerosols, forms, based on proportion of solid particles, dilute suspension 2 to 10%, wet volume solid, for example, cortisone, acetate, prednisol acetate. Number 3, based on behavior of dispersed phase. Number 4, based on size of dispersed particles, molecular dispersion, colloidal dispersion, in which there's size is given, particle size less than 1, and coarse dispersion, particle size is greater 0.2 micron meter. Number 5, general classification of suspension. Oral suspension, example is paracetamol suspension. Topical suspension, concentration of exceeds 20%. Wet volume, example is calamine lotion. Calamine lotion, which we were prepared in our laboratory on small scale. So some properties of suspension here are: a well-formulated suspension should have easy and rapid dispersion of sedimented particles for uniformity of dose, no cake formation and sedimentation, optimum viscosity for pouring, physical and chemical stability, free from grating particles in case of external use. Advantages, disadvantages, you already knows what are advantages, disadvantages. Suspension can improve chemical stability of certain drug, for example procan penicillin G drug in suspension exhibits higher rate of bioavailability than other dosage forms. Solution, suspension, capsules, compressed tablets, coated tablets. Duration and onset of action can be controlled. For example, protamine, zinc, insulin suspension. Then some disadvantages, every dosage form uh, contain advantages and some disadvantages. Physically stability, sedimentation, and compaction can causes problems. It is bulky, sufficient care must be taken during handling and transport. It is difficult to formulate. Methods formulation, precipitation method, precipitation methods are used. Organic solvents precipitation, precipitation by pH, double decomposition. These three methods we have already discussed. And dispersion method, use of controlled flocculation, mm, methods for formulation of suspension, for use of structured vehicle called also thickening or suspending agents. They are aqueous solutions of natural and synthetic gums. In this semester, you have to focus on formulation and equipments of the uh, manufacturing, which we are using in process of manufacturing, which equipments are used, which uh, uh, formulation of suspension have been designed. And so these are some points you have to remember. It causes difficulty in pouring and administration. It may affect drug absorption since they absorb on the surface of particle and suppress the dissolution rate. Structured vehicle is not usable for parental suspension because they may create problem in syringeability due to high viscosity. Yeah. Here is a reference of a book from I have made these points. Formulation of the general procedures. First, the particle size is reduced to desired size with the help of mill or other equipments. The insoluble material are navigated or grinded to smooth paste with the vehicle containing the wetting agents. All soluble ingredients are dissolved in same portion of the vehicle and added to the some smooth paste to get slurry. If preparing on small scale, the slurry is the transfer to a graduated cylinder and mortar is rinsed with the successive portion of vehicle. If preparing on industrial scale, then slurry is transferred to a colloid mill or disperser or any other equipment to completely wet the particles. Then a defloculated suspension is obtained. Decide whether the solids are suspended in a structure vehicle, flocculated, and then suspended. This is a flow chart for formulation of suspension. You can see the chart on the screen. Flow chart for formulation of suspension. This is in the other chart, which is related with the first one. And some components, which components we are using in suspension formulation. Suspending agents are also known as hydrophilic colloids, which form colloidal dispersion. Suspending agent form film around particle and decrease interparticle attraction. Most suspending agents perform two functions. Besides acting as a suspending agents, they also impart viscosity to the solution. So these some suspending agents are here: sodium alginate, methyl cellulose, hydroxytyl cellulose, hydroxypropyl cellulose. These are some suspending agents. Wetting agents: hydrophilic materials are easily wetted by water, while hydrophobic materials are not. However, hydrophobic materials are easily wetted by non-polar liquids. So components there are surfactants also. Surfactants decrease the interfacial tension between drug particles and liquid. Thus, liquid is penetrated in the pores of drug particles, displacing air from them and thus ensure wetting. These are some surfactant uh, uh, or hair polysorbate at is most widely used due to following advantages. It is non-ionic, so no change in pH of medium, no toxicity, safe for internal use. Hydrophilic colloids. Hydrophilic colloids coat hydrophobic drug particles in one or more than one layer. Then solvents also used, the most commonly used solvents used are alcohol, glycerin, polyethylene glycol, and polypropylene glycol. These are some solvents which are used. Then buffers. Buffers are materials which, when dissolved in solvent, will resist and change in pH when an acid or base is added. Buffers are very important to encounter stability problems. All liquid formulation should be formulated to an optimum pH. Then preservative, naturally occurring suspending agents such as tragocont, acacia, xanthan, and gum are susceptible to microbial contamination. This leads to loss in suspending activity of suspending agents, loss of color, flavor. Then flavoring and coloring agents are very important to aid a flavor or to, when we mask and any test, we should uh, add the flavoring agents because some uh, active or very bitter in taste. So we are adding some flavoring agents to mask the taste. And then coloring agents uh, on the design, it is depend on the design of the dosage form, which color can be used for adults and children. Separate colors are using colors are obtained from natural or synthetic sources. The synthetic dyes should be used within range of 0.0005 to percent to 0.001%. Color adds in the identification of the product. The colors used should be accurately. Most widely used colors are as below. Some colors names are hair, titanium dioxide, white, brilliant blue, blue indigo, carmine. These are some names of the coloring. Then sweetening agents also, we are using sweetening agents. They are used to test masking of bitter drug particles, sugars such as xylose, ribose, glucose, mannose. Sweetening agents also we use for the bittering test. Humectants absorb moisture and prevent degradation of API by moisture. Examples of humectants most commonly used in suspension are propylene glycol, glycerol. Total quantity of humectants should be between 0 to 10%. Antioxidants also used in suspensions. Ascorbic acid derivatives such as ascorbic acid, erythropobic acid. These are some antioxidants uses. Here a reference. I have given reference and pages number also, you can see from the book in detail. So we are coming on equipment for suspension. Main uh, uh, focusing topic is equipments. You have focus in this semester on equipments. Which equipments are used in industry, larger scale? You should know about them. Inshallah, we will visit also one to and pharmaceutical good industry where you are observing. You will see the all the equipments which are used on large scale. Here motor and pestle, which is on small scale, and then agitators, mechanical stirrers. Suspension may be prepared by means of various propellers produce axial movements, turbines produce radial and tangential movements mounted on shafts. For low viscosity suspensions, propeller type can be used, but for higher viscosity, turbine type is used. So the advantages can be used for small scale production and laboratory purpose. Agitator also use uh, can be used on small scale, and continuous checking tends to, yeah, this is disadvantage, that continuous checking tends to break up not only the phase to be dispersed, but on this way impairs ease of suspension. These is images of propeller agitator, turbine agitator, anchor agitator, spiral ribbon agitator. You will see in industry this type of agitators. This type of agitators you will see, and colloidal mill. Then colloid mill. The principle of operation of the colloid mill is the passage of the mixed phases of suspension between a stator and high-speed rotor revolving at speeds of 2000 to 18,000 RPM. The clearance between the rotor and the stator is adjustable, usually from 0.001 inch upward. The suspension mixture while passing between the rotor and the stator is subjected to a tremendous shearing action which affects a fine dispersion of uniform size. The shearing forces applied in the colloid mill usually raises the temperature within the suspension, and the coolant is used. This is the image of the that polite mill. It was a very high shearing force can be generated. Very fine particles can be prepared. Particularly useful in preparing suspensions containing poorly weighted solids. Useful for preparation of relatively viscous emulsions. Some disadvantages are also available. It has no wide application in solids. Wear of the rotating plates, and no fine grinding, consume energy. Homogenizer, impeller type of equipment frequently produce a satisfactory emulsion. However, for further reduction in particle size, homogenizers may be employed. Homogenizers may be used in one of two ways. The ingredients in suspensions are mixed and then passed through the homogenizer to produce the final drag. The core suspension basic enters the valve seat at the high pressure, 1000 to 5000 psi. Flows through the region between the valve and the seat, high velocity with a rapid pressure drop causing cavitation. Subsequently, the mixture hits the impact ring, causing further disruption, and then is discharged as homogenizer product. Sometimes single homogenization may produce an emulsion which, although the particle size is small, has a tendency to clump off from clusters. So this is the homogenizer equipment for suspension. Then piston homogenizer. It is the most powerful device for producing emulsions and suspensions. It uses high power positive displacement piston type of pump, produce pressure 3000 to 10,000 psi, and then force the pre-mixed product through the especially designed restricting valve where extremely high shear forces are exerted. This is piston homogenizer. This is image for the piston homogenizer. Ultrasonic device. And ultrasonic device also used for the preparation of emulsion by the use of ultrasonic vibrations also is possible. An oscillator of high frequency 100 100 100 500K is connected to two electrodes between which is placed a piezoelectric got oil bath, and when the oscillator is operating high frequency waves, some are advantages can be used for low viscosity and extremely low particle size. Disadvantages only in laboratory scale it is possible. Large scale production is not possible. So this is the ultrasonic. So these are some equipments. Inshallah, in next lecture we will discuss other remaining topics related to the suspension. So some equipments are also size reduction equipment. As my laptop charge is by an ending, so it is uh, there is no time to discuss in detail, and inshallah next lecture will continue from here. So we will discuss equipments and the remaining related topics about the suspension. Wish you best of luck, inshallah. Very soon we will meet you physi- physically and conducting classes and cover the will cover inshallah all syllabus.